Object-oriented programming is a huge topic. There are many techniques and technicalities to learn in C++, not to mention other object-oriented languages like Smalltalk, C#, Java, Python. And not all object-oriented languages are equal, but they generally fall into three main categories. So one category are the pure object-oriented languages where everything is treated consistently as an object. Smalltalk is an example of that. A second category are languages designed mainly for OOP, but with some procedural elements. Java, Python, C#, C++ fall into those categories. The third category would be languages that are historically procedural but were later extended with some object-oriented features, languages like Perl, PHP, MATLAB, and so forth. So C++ provides built-in types like char, int, double, but through the years, programmers needed more capabilities, specifically a way to create user-defined types, we call UDT, providing a means to more closely model real-world things, which we call classes, and to better control instances of these real-world things, which we call objects, by judicious planning, think design, and execution, think implementation. So procedural programming can be likened to a garage attached to a suburban house. The structure of the garage can be thought of as the computer hardware and operating system, with doors for input and output, with knobs and garage door openers as operating system services. Studs and rafters for attaching things to, etc. And then the open spaces, the open space of the garage, you can think of as memory for your data and for your programs. So the open spaces, or a garage space, can hold many different things like cars, tools, boxes of old clothes, books that don't quite fit inside the house, random camping equipment, bikes, toys, dog food, cleaning supplies, bug spray, leftover paint, garden tools, etc., etc. And these are the data for our programs, right? And use variables to represent interesting facts about them, characteristics like where things are located, how much space they take up, who owns them, their color, their condition, etc. So to model valid uses of this representational data, these variables, we use statements to discover, interpret, change, and store what is represented. So the statements operate on the data. Statements can be considered behavioral, whereas variables can be considered state or data. So to discover, which is to read, to interpret, which is to analyze, change, which would be to transform, and store outside your program or to write that data out somewhere to storage. So for instance, a car can be started and backed out of the garage. A ball can be picked up and bounced repeatedly. Bug spray can be aimed and released in the general direction of a pest. Starting the car, bouncing the ball, spraying the pest are all actuated by program statements. Now, the owner of the house may decide what should and shouldn't be stored in the garage, and may even have definite ideas about the way things should work, or the processes, the program statements. But enforcing these rules is harder than it sounds, since, let's say, a family, mom and dad, sons and daughters, all have free access to the garage, and may not follow the garage owner's ideas of what to store, where to store it, and what rules govern what can and should be done to items in the garage and what should not. So think of code and data as the things that we're storing in our garage, or the things we're storing in our memory when we write programs. So maybe while dad or mom is at work, Junior unboxes stuff all over the garage floor but doesn't clean up after himself. Dad comes home tired after a long day at work, and drives into the garage, breaking all manner of expensive toys, and perhaps he even gets a flat tire. So that's kind of the view. The longer your C programs get, you can impose a good structure, but it takes a real expert. And when you're dealing with large programs that are not trivial and lots of people working on a team, these are the kinds of things that, programmers have to deal with. And so back in the 80s and 90s, when Bjarne Stroustrup was working at Bell Labs and working with C language, he created C with classes because he wanted to come up with a way to improve the quality of programs, and how could he help himself and help programmers make fewer errors. And so he came up with C with classes, which then eventually became C++. So object-oriented programming, using the garage analogy, provides a way to define representational data and the rules for how to access that data and enforce things like putting toys back in the box and putting the box back on the shelf before Dad comes home and collides with the toys that were left laying around in the procedural programming paradigm. So with object-oriented programming, we define data, so think representational state. We define behaviors, think legal operations on data. And we bind them together as a unit, known in C++ as a class, which you can think of a blueprint or a recipe, and then modeling those classes in our program, bringing them into being, as it were, instantiating them as individual objects. So a car is an object. And if you have more than one car, then you'd have more than one object. You would instantiate an object of, a Chevy HHR, and then you'd instantiate another object for a Ford F-150 pickup truck, right? And so that is how programmers in the object-oriented space and designers of these programs try to manage complexity and try and create a more cohesive type of expressing programs that are safer and that are smarter and that are easier for people to use, other programmers. So mom, dad, son, and daughter are all objects made from the same class, maybe a person class, while the car may be made from a vehicle class, the ball being made from a toy class, etc. So that's kind of the flyover of why object-oriented. In my next several videos, we'll explore how to model and implement a simple date class, date like today, May 1st, 2021, and how to use a date in your program. But it's a really good concept to really show the dangers of not using objects and what object-oriented programming in C++ brings to the table over C.